Hey, hello and welcome to another video. I hope everybody's doing okay. Today I want to talk about the stack pointer. Now, the stack pointer is an important register right here. It is R13 and we want to understand how this works. Basically, it implements a stack. A stack is something super useful. You could push items into the stack and then pop items out of the stack. The convention that it follows is last in, first out. A better or simple understanding of this is uh, visually fairly straightforward. Let's have a look at what a stack really does. So essentially, it's just consider it as a basket, okay, and you can push items into it. So you could push some item here. Say you put a push a number 5 and then 4 and maybe 2. So you could push items into this basket. So as you push items, they get stored, but they get stacked on top of each other. Hence the name stack, right? So notice whatever you pushed first is at the bottom. Okay, this is why this follows the convention, which is LIFO, last in, first out. Because now, when you're going to pop items out of this stack, what's really going to happen is you're going to be accessing the item that you stored or pushed at the very end. So this is the first item that goes out, and then 4 goes out, and then 5 goes out. See, last in, which was 2, and this gets out first, right? So this is why we call it the LIFO. Oh, let me write it here again. Last in, first out. Okay, so LIFO. This is why it's called last in, first out. Whatever is at the end, whatever's been pushed at the end, gets popped out at the very start when you're popping. Okay, so that's the basic functionality of a stack. Now let's have a look at how this aligns with um, the assembly programming. So I've got a bunch of lines of code and I want to go over them one by one. From line 5 to 7, I'm already in the debug mode and I've got these breakpoints set up, so I'm going to go over them one by one. From line 5 to 7, I am moving 3, 4, and 5 in registers R3, R4, and R5. So this is pretty straightforward. Let's actually go ahead and step through these three lines. I can see 3, 4, and 5 in R3, R4, and R5. So that is super straightforward. Now, what happens here is I use the command push, and it's pushing the value of R3 into stack. What's in R3? I've got 3 stored in R3, okay? So it's going to push 3 into my stack. Meaning, if this was my stack, in effect, let me in fact draw another stack on the side of this. So if this is my stack now, and I am going to push, say, 3 into this stack, and I also want to have a look at my stack pointer. My stack pointer is pointing at 200, okay? So 200, and this is in hex. We convert it in decimal, it's about 512. So basically at 200, and then this time I'm going to write memory addresses here, because I am now specifying that this is in fact a stack pointer that's pointing a memory location. So it is at 200. I'm going to write the value here in a different color. I'm going to write the value in red. Okay, so at 200, I could see that there's absolutely nothing in my stack. I've not executed this command, so I actually shouldn't be writing 5 here, because at 200 there's absolutely nothing in the stack. But when I execute this line, what I should expect is some decrement or increment or some difference in the address location that the stack pointer is going to point to, and I will see, and I should have in my stack the value stored in register R3. So let's go ahead and do this. So when I do this, and this line 8 has been executed, and what I can see now is that stack pointer is 1FC. 1FC is in decimal is then 508. So from 200 to 1FC, that's where we are at. And I'm going to go ahead and move my stack pointer to 1FC in decimals from 512 to 508. That's where I'm at, right? So that's 1FC. So basically, stack pointer has moved, it's moved 4 bytes. And in my stack now, I have the value that was pushed in stack, or what was stored in R3, which was the number 3 itself. Okay, so this I am going to go ahead and write here in red. So I've pushed a value in stack. There's that value, and my stack pointer has moved. It has decremented 4 bytes. Okay, I keep pushing another value, which is whatever stored in R4, which is 4. So I push another item in the stack, and I'm also going to expect my stack pointer to further decrement from 1FC to 1F8. Okay, so I am expecting now that my stack pointer is going to decrement. Okay, I can see that this stack pointer is now pointing at a different memory address, and I also pushed something in stack, which was 4, right? So these two items are now in stack, and this is the updated location of the stack pointer. So this is something I can very clearly see now. And this is also validated by this R13 register, and it's storing the address location of where the stack pointer is pointing to, right? We're talking about the main stack pointer. Now we execute line 10, and from 1F8, this has now become 1F4, and we've pushed whatever was stored in R5, which was 5 itself, right? So let's go ahead and update the stack pointer one more time. What this really means now is we are pointing at 1F4. Notice there's a decrement of about 4 bytes, and now we have 5 pushed into the stack. Okay, so this is how my stack functions in assembly programming. Okay, and this is my latest address that the stack pointer is pointing to, 1F4. This is the order of this is the sequence in which my items or my values are stored in the stack: 3, 4, and 5. Notice 5 is on top of the stack, then 4 and 3 is at the bottom of the stack. So now I'm going to go ahead and execute the pop commands here. Now the convention or the syntax for the pop commands is that it just pops whatever is at the top of the stack. That's the way the stacks work. So 5 is at the top of the stack, and the syntax here tells me, okay, whatever is at the top of the stack, move that value to register R6. So what we should be expecting now is 5 to be stored in R6. That is what we should be, because 5 is at the top of the stack. What we should also be expecting is that the stack pointer pointing here should now, once this has been popped, be pointing at 1F8. Okay, so it's currently pointing at 1F4. Let's go ahead and execute line 11, and we do see that the stack pointer updates, and in R6 we get the value of 5, right? Because 5 was at the top of the stack. So let's go ahead and just make a note of the updated location for stack pointer. I'm just going to go ahead and overwrite this thing with the red arrow, that this is my current location of the stack pointer. Notice 5 has been popped. This is the top of the stack now, which has 4 stored in it. 5 went into R6. Now the next item is going to go into R7. If I pop the stack now, meaning what's on top of the stack is 4, 4 is in fact going to go to R7. Stack pointer is then also going to increment this time. Remember, we're coming back. So that's what we see. Now points to 1FC. R7 in fact has 4, which was the top of the stack. Okay, so we are now currently at 1FC. That's how we can keep track of where we are. Where is the stack pointer pointing to? It's pointing at 1FC, points to the top of the stack. That's important to remember. It's pointing to the top of the stack all the times. So what's at top of the stack now? It's 3. Remember, 5 and 4 are no more part of the stack. They've been popped out. So the top of the stack is 3. It's pointing at 1FC. We can confirm this point R13 stack pointer pointing 1FC. Top of the stack is the value 3. It's going to get popped into register R8. Right? R8 has nothing. Let's go ahead and do this. And there we see R8 now has 3. So we've gone and pop this, and the stack pointer comes back to 200. Okay, so we could make a note of this here again by showing that the stack pointer is in fact at 200. Okay, so it's back to where it was originally. So this is how we can push items in the stack, and as we push, remember the addresses that the stack pointer points to, they get decremented by 4 bytes. And as we pop, as in take items out of the stack, the ones at the top first, the stack pointer then increments back by 4 bytes. And each time we pop, we have to specify where do we really want the top item to be placed now, right? And the convention or the syntax difference between the push and the pop really is this. You push whatever you have in any register into the stack, and while you pop, you have to specify where do you want that item on top of the stack to be placed at, right? So you have to specify a destination register. All right, so I hope that makes sense and we understand the difference between pushing and popping and the implementation of stack in assembly language. If you have any questions, feel free to drop your comments. We're happy to answer them. Thank you so much.